Um, Hello, everyone. My name is Enrico Surto, and I'm here with my good friend, Dr. Bogner. Dr. Bogner, thank you for joining us today.
Thank you, Enrique.
So it's really a pleasure to have you back with us, and we're going to be discussing some very interesting things. Before we start um, with the session, I'm just going to introduce Dr. Bogner for those of you who don't know him. Dr. Bogner, he's a researcher and he is an ASD dad himself. Dr. Bogner strives to bring forth cutting edge therapeutic options for his patients. He has lectured both nationally and internationally on autism spectrum disorders. Dr. Bogner's goal is really to optimize each affected individual's path for recovery by integrating the latest research in genetics through nutrition and targeted nutraceutical supplementation, exemplified by his accomplishment receiving a certificate in plant-based nutrition from Cornell University, and also he recently got his certification on functional medicine. In this live educational session, Dr. Bogner is going to provide a deep dive into the interpretation of recently conducted genetic mycotoxin and neurotransmitter testing and personalized recommendations for the case of two brothers on the autism spectrum. So very interesting session we're going to have today. And Dr. Bogner, I just want to let people know that you are actually launching your own practice, and we're very excited to see you doing that. And I'm just going to kind of pass the ball over to you, and I hope that people can really get a lot from all the information you're going to be sharing with us today. So thank you so much for being with us today.
Yeah, thank you, Enrique. And we've been friends for a while, and I'm really amazed about everything that you do with your group. You have fascinating researchers, top notch, on your site that you interview. So I'm probably have watched most of them, and it's fascinating. We're all in the same boat. We all learn from each other, and it's only for the benefit of our children affected with autism. And I think we're finally getting somewhere, really. And it's thanks to people like you, fathers, researchers, doctors, doesn't really matter. Whoever puts an effort in to, find solutions for our kids is my hero. But yeah, today, what I wanted to do is just give a general overview of what I believe autism is all about. In no way do I have the whole puzzle figured out, but it's a general overview, I think, with a approachable and actionable things that we can consider. And so but if you have any questions, let me know. But otherwise, I just get started. I've created all of these slides today, so excuse my slides, they're not perfect. So yeah, my name is Dr. Bogner. I'm a certified functional medicine and nutritional practitioner. I'm also board certified OBGYN. I have a plant-based nutrition certificate from Cornell University, and I've got interested in autism about 12 years ago. My son is affected with autism. He's 16. And once I started researching autism, I really dove deep into it. Year after year, started to be present at the Autism One conferences, met a lot of good people, learned a lot. But over the last 4 years, I've intensively engaged only with mostly, but I would say only with patients affected with autism, some peripheral diseases, in regards to cognitive enhancements, Alzheimer's and schizophrenia. But my focus is always autism because I'm in the same boat as you. I'm a father first and foremost, and that's what my life goal is, to find solutions for our kids. So I have started my own clinic. It's called Bogner Health. If anybody wants to contact me, you see my email here. I'm also present on Facebook, Dr. Bogner, and you can also visit my website, which is still being built. It's not perfect, so be patient, please. So let's get started. So, a disclaimer before anything, this is really important. The information that I'm providing today is for general informational purposes. All information is provided in good faith. However, I make no representation or warranty of any kind, express or implied, regarding the accuracy, adequacy, validity, reliability, availability, or completeness of any information. Under no circumstance shall there be any liability to you for any loss or damage of any kind incurred as a result of the use of this information or reliance on any information provided today. So before you implement any changes on your own or for your loved one, please consult your primary care physician or another health professional. So we're going to start with this. Enrique, I put your picture in there because I thought it was funny. Not really. But we're starting today, with autism. I thought we start with the gut. Because we have to start somewhere. When you look at the big picture, it's a lot of puzzle pieces. So which one would you pick first? Well, let's just go and start with the gut. So I want to introduce some of the concepts that I've been working on and have implemented into my practice. And later on, after we have completed that, I would like to introduce these two patients, describe the testing that they had, and then implement them into these slides so we can all learn and make sense out of that, because it's pretty complex. So our adult gut is about 20 feet long, as you can see here from top to bottom. It's a large organ, and if we, for example, take a cross section of the small intestine here, where we see that there is inflammation present. We can identify the term that we all know called leaky gut. And let's assume that in this area where food is digested, protein digested into amino acids and then absorbed. And if we have an area in the gut, as you can see here, that is inflamed, the intestinal barrier is somewhat broken. What I mean by that is that usually the intestine only absorbs small amino acids and nutrients by active transport. However, if the gut is inflamed, these barriers are broken. And as you can see here, everything in our gut, from top to bottom, everything is absorbed through this portal system here into the liver. So nothing really that we ingest immediately enters our bloodstream, our peripheral bloodstream, before the liver, which you can think of our border patrol, is vetting everything that's coming in. And so everything is absorbed right here, which includes also, if the gut is inflamed, protein. Protein that should have been digested in the gut gets absorbed as well as toxins that maybe should have, kept passing in the gut. They all get absorbed now because of the inflammation. Now, in the liver, usually toxins get filtered out, and they get filtered out usually by binding to glutathione. Glutathione is our most powerful antioxidant that we have, but it's also a very powerful binding molecule. It aids in inflammation. It reduces free radicals such as superoxide dismutase or hydrogen peroxide. And it binds toxins, anything from aluminum. We have about 30,000 registered toxin with the EPA that are used in the industry. So a lot of them are exposed in our food, in the air, in our houses. And so it's really not critical to address any specific toxins because the liver knows how to deal with them mostly because of glutathione. And so we have limited amounts of glutathione in our body, but about 70% of glutathione is produced in the intestinal tract and in the liver because, that's the first entry, the first really organs that get in touch with these toxins, because most toxins that we consume are obviously is what we put in our mouth. Most of the rest of the glutathione is actually in the lungs and in the kidneys. In the lungs because of the toxins that we inhale. And so glutathione is very critical. However, if we are depleted of glutathione in the liver because we have a leaky gut and a lot of toxins, a lot more toxins than usual are coming in, our glutathione reserves are quickly depleted. And as you know, there are many studies in the autism literature that describe low levels of glutathione in autism. And it's not just the mass effect of toxins and chemicals and protein coming into the liver that deplete glutathione. Later on, we will also discuss problems that are genetically that we have with the production of glutathione. Glutathione is requiring the assembly of different amino acids. In fact, it's glycine, glutamate, and cysteine that need to be basically fused together, and that's all done by genes. And those are the genes that we're going to be talking about as well. So there are production problems and the toxins from the environment that stress the liver. And the reason I'm mentioning and stressing this is because if we don't have the ability to grab toxins and chemicals in the liver, now we're starting to enter the peripheral circulation, and that can go anywhere, to the brain, to the kidney, to our bones, to our kidneys, to every organ, really. This should be really just supplying the body with nutrients, vitamins, minerals, and amino acids, not toxins, protein of any sort. If protein enters the bloodstream, there will be consequences. The body, in fact, recognizes protein in the blood that gets absorbed by the liver as foreign, as an antigen, such as a bacteria or virus. So when we take a cross-section of one of these peripheral arteries, or rather peripheral veins that collects all these nutrients to go to the heart and then to be pumped into the peripheral circulation, you can see here in this graph, for example, these white molecules that you see here could be really anything. Could be gluten, a gluten protein that passed through, that didn't get processed correctly in the gut and leaked through, a casein protein from dairy products, any sort of toxins, really, including mycotoxins that we're going to be discussing, as well as protein. And so the consequence of that, when a protein, gluten, casein, or toxin enters the bloodstream, is that histamine gets released. And a good example of that is that, for example, let's bypass the liver and inject something into our body, such as a mosquito bite, let's say. You get bitten by a mosquito, and immediately you can kind of feel that because it's itchy and it's red. And what happens is that histamine is basically released in that area where the mosquito bit you, because the body wants to dilate these blood vessels around the toxin so the immune system can come in and gang up on that toxin to quickly neutralize it. For example, if you have a bee sting, some individuals react very violently. The toxin is a little bit more harsh than a mosquito bite, and some people have massive amounts of histamine released because of that. And that can have such a big consequence that the whole peripheral arterial system starts to dilate, and the heart can't make up for it. And when that happens, you are in vasogenic shock, you're in anaphylactic shock, and you go to the ER, and the only way to save you is really with adrenaline. And we'll get to that in a second. So histamine gets released immediately with any contact of any sorts, of any foreign protein or toxin. And, in addition to that, when you have gluten or casein, for example, you have IgG-mediated autoimmune processes that could develop. With continued exposure, some of the proteins, for example, in gluten and casein, the amino acid sequences look structurally similar to some of our own body's amino acid sequences, and the immune system cross-reacts. And hence, for example, some individuals do something called the Cunningham panel, where we see autoimmune-mediated, for example, immune reactions to the myelin sheets or to the glutamate receptor of some sort. So I don't do the Cunningham panel, but you can see where some of these tests come in handy. But the question is always, you do a Cunningham panel, what are you going to do about it? Are you going to provide IVIG, for example, to grab the chemicals so our own immune system doesn't get to them, I don't think that's really a solution. It's not really addressing the root cause. But really what we're after here is that, and there are many effects of histamine, of course, but I want to be really focused on what I believe is the root cause of autism. And so histamine will stimulate adrenaline release in the adrenal medulla. And that's a known fact. Why is that happening? Well, if you think about it, when we had that bee sting and we had anaphylaxis, what saves us is adrenaline. And so it's kind of a defense mechanism of the body to release adrenaline, to burn the histamine, to prevent anaphylaxis, so we don't die. And so it's in fact a very survival mechanism that the body initiates with that. And so adrenaline gets released with histamine now. And that would explain a lot of the soft behaviors that we can start to mention. For example, these kids oftentimes have high pulses. They breathe heavier. They have excess energy. They're hyper, and adrenaline suppresses melatonin. There are enough studies out there, I think, that we all know that children affected with autism have low levels of melatonin, and the adrenaline is part of the reason for that. But what I'm really after is that the adrenaline is a big stimulant for cortisol release. And that is very, very critical because cortisol is a steroid hormone. If you think about, for example, a patient affected with rheumatoid arthritis, in some decades back, the initial treatment for rheumatoid arthritis was cortisol. And why is that? Well, in rheumatoid arthritis, it's an autoimmune disease. The immune system is attacking the joints. For example, the little phalanges here in my hand. And that creates a lot of immune reactions in my joints in my hand, which causes my hand to swell. And so it's very painful for me to move my hand. And one of the treatments used to be, and in some countries still is, and even in this country, some doctors still believe in cortisone injections. So you inject cortisone, and what happens is that the cortisone is suppressing these cells that were attacking the joints in my hand. And so all of a sudden I can move my hands again because the immune system took a hike. But why do I tell you about rheumatoid arthritis? Well, the reason is that cortisol, which is basically the same idea as the cortisone that is being produced pharmaceutically, is suppressing these specific immune cells. So they suppress other things as well, but the CD4 and CD8 T cell mediated immunity. And that is very critical because once these cells are neutralized, it's very critical because these cells are also responsible for dealing with yeast and mold. And specifically in autism, there's a lot of discussion right now about Aspergillus mold. The question is, why do these children have mold? And that could be part of the explanation, is that the reason is that these children are immunosuppressed. They're immunosuppressed from high levels of cortisol, high levels of adrenaline, and high levels of adrenaline because of histamine imbalances. And the histamine imbalances are, again, because of the liver stress that occurred due to a leaky gut. And so now, before we get into the genetics, you can see how this is a never-ending cycle once you enter it, because the Aspergillus mold will create more leaky gut, will deplete the liver more. The liver depletion causes more toxins to enter the blood, which causes more histamine. The more histamine causes more adrenaline. The more adrenaline causes more cortisone, more immunosuppression, and so forth and so forth. With that being said, cortisol also, adrenaline, I'm sorry. Adrenaline is our fight or flight neurotransmitter. And we all know that, if you've been in a situation that was very scary or you were in shock, you can appreciate that you are very, very alert in these times. And you also have almost super strength. And the reason for that is that adrenaline mobilizes blood sugar, and it mobilizes those mostly from quickly accessible sugar. And that is usually in our muscles, in our skeletal muscles, and in glycogen in the liver. So when adrenaline stimulates the release of those sugars, it's because our body wants us to be strong in dangerous situations. It wants to have the sugar readily accessible in those areas. It shifts the blood away from the gut. You don't want to digest your food while you get chased by a bear. You want to have all of the energy mobilized to those organs that will save your life. And so what happens with adrenaline is that a lot of sugar gets released. And the consequence of that is that insulin levels rise. In any high blood sugar situations, insulin rises. And when insulin rises, blood sugar consistently drops. Let's say the danger is over. Well, insulin sticks around and will keep dropping your blood sugar. Why is that important? Because in autism, we see oftentimes the children are craving sugars. And they're craving sugars because they're crashing. They're crashing their blood sugar because of the high adrenaline that caused ultimately the high insulin levels, which then lower the blood sugar. And once you reach a certain threshold of low blood sugar, because of the high insulin, the body obviously doesn't immediately die. Well, there are mechanisms that exist when the blood sugar drops, and that mechanism is more adrenaline is being released to make up for the declining blood sugars. And that's when some people say, if they don't eat, they become hangry. They're hungry and they're angry. It's because their blood sugar drops and adrenaline is released. And as we will see later, that adrenaline is a big problem in a lot of people because they genetically have problems breaking that down. So let's bring in the reason why autism develops, because what we've discussed so far is actually happening in a lot of people, and a lot of Americans and a lot of people worldwide. This is a mechanism that exists. I've tested non-autistic adults, non-autistic children. A lot of them have mold problems. And it's not that you have to have pain in your gut or diarrhea or constipation. It goes unnoticed. It doesn't cause pain, just like you don't feel when you digest your food. But a lot of people have that problem. But what is really the deal with autism? How does that play into everything? And unfortunately, that's why we have to get into genetics. And just a little 101 on genes here. A gene really is part, it's the smallest part of a chromosome. And a chromosome is simply coiled up DNA. And as you can see here, we have about 20,000 genes as humans, 20,000 from our mother and 20,000 from our father, to keep it very simple. And for example, one of the genes that many of us are familiar with is the MTHFR gene. And if we talk about MTHFR, for example, let's think of it as a little sequence here on the DNA. And the fact is, like I mentioned, we have one copy of our MTHFR from our mother, and we also have one copy of that from our father. However, both of us might have given us a different copy. And what I mean by that is that, for example, if our father gave us an MTHFR copy with one of the sequences here that are different than usual, for example, if there is a C instead of a G here, then the gene still works. However, what the gene produces, usually an enzyme in this case, the enzyme is folded a little bit different three-dimensionally, and it doesn't work as good as the original copy. But again, it doesn't mean that this is a gene deletion or any or non-functional gene. It's still working. However, in this case, for example, if we have a patient with an MTHFR SNP, we call it a single nucleotide. Those are nucleotides. Polymorphism, meaning it's a substitution of a nucleotide. And when we have a good copy from mom, which works great, producing great enzymes, we have a weaker copy here. And that reduces our whole ability in our body to produce the MTHFR enzyme, MTHFR is an enzyme, by about 30 to 40%. And many of us have it, and we live normal lives. It's no big deal. However, if both of our parents give us a compromised copy, we call that homozygous SNP of MTHFR, the function of this gene is about 60 to 70% reduced. And now, well, we still can live normal lives. However, we make much less of this gene, and we'll see what consequences this potentially could have for our organism. So let's talk about adrenaline. So we mentioned that adrenaline gets produced in cases of leaky gut, low glutathione in the liver, and also with high histamine states. So, for example, adrenaline usually in physiologic conditions breaks down to metanephrine. That's how adrenaline breaks down. And that breakdown is done by a gene called COMT, catecholamine methyltransferase. And a gene, usually, like I said, we have 20,000 genes, but they don't just all express themselves at the same time. Genes require a signal from the environment, such as a vitamin, for example. It's like you have an engine here, but the car doesn't drive until you give it some fuel, or you have a key, for example. Sometimes these genes require multiple stimulants to go and work. So in this case, in order to break down adrenaline, we need methylation energy. And that's in the form of S-adenosyl methionine. And we'll get to how this is being produced. But that's basically adrenaline needs to be methylated to get towards metanephrine. Also, magnesium helps with that process. And that's why products like Calm, for example, exist. You know, Calm is a magnesium powder. It's called Calm because it's supposed to calm you down from the stress of the adrenaline. And it does work. However, it's oftentimes not enough. Now, how do we get to the SAMe? So if we look at here at these genes, we have MTHFR and we have MTRR. And these genes will come in handy later when we plug in the genes of these patients, because these are the critical genes that we're looking at when we're counseling patients. So, for example, the function of MTHFR is very simple. All it does is convert mostly dietary folates in the form of, folic acid, to simplify it mostly. And our food nowadays is fortified with folic acid because most of folic acid is actually found in vegetables, in green leafy vegetables. But because not all of us eat green leafy vegetables every day, several decades ago, they added folic acid to our diet, cereal, pasta, bread, flour, and they fortified our food, which in my opinion, well, I might not want to comment on that. But MTHFR simply activates that vitamin B9 into the form of the B9 that we can use. And the same is happening on this side with vitamin B12. Vitamin B12 gets absorbed mostly from fatty fish and red meat, highest in liver, animal liver. And the MTRR gene simply converts the inactive form of B12 into the methylated form of B12. And the reason this is important is because both of these methylated vitamins aid in the production of SAM. And what fuses these two methylated vitamins together is this gene called MTR, which in my opinion is one of the most critical genes that is really not discussed a lot. However, it's really a key central gene that you will see is critical in producing this final methylation energy that we can use. And SAM is not only used for the breakdown of adrenaline. In fact, SAMe and methylation energy is used in over 300 processes in the body, but specifically, I wanted to focus on this today. So now let's bring in serotonin. So serotonin is another neurotransmitter that we have. And serotonin, in the most simplest terms, gets broken down in the body by the gene called MAO, monoamine oxidase. And it gets broken down into 5-HIAA. Many of you might remember that from your OAT tests. but it's really not a good marker of serotonin function, because you can have low 5-HIAA and have low serotonin. And you can also have high serotonin and low 5-HIAA. So I would be cautious to interpret those O-tests neurotransmitter section that you have, I think it's page 2, to really have a true reflection of your neurotransmitter status. But the reason I bring the serotonin here right next to the adrenaline is because MAO is a little bit different. It's a little bit different to MTHFR or COMT, for example, because we only have, when you are a male, like in these two patients that we have today, MAO is only present on our X chromosome, one of our sex chromosomes. And since males have XY chromosomes, we only have one. And females have 2 X's, so they have 2 MAOs. The reason this is important is because if we have a compromised version of this MAO, our ability to break down serotonin is has a much greater reduction than, for example, a female, or at least the chances that the reduction is great are much higher. In fact, that's why I believe one of the core reasons that the autism ratio between males and females is about 4-to-1. And the same is true for schizophrenia. And so we call this hemizygous if you're affected. If you look at your genetic tests, for example, I don't know what tests everybody's doing, but we use MaxGen. And when they report these genes, they always say plus minus, basically meaning plus there is a variation in that gene from one of the parents, and the minus means, oh, there's not another one from the other parent. And so when this is being reported, it's actually reported wrong because there is only one. But that's why you have to look into the fine prints of what exactly you have. And so the MAO gene is only transferred by mama. Now, it will get more interesting once we plug in the genes of these patients. However, now you see, for example, let's have aluminum come in. Aluminum is a very potent inhibitor of MAO. And when you have an inhibitor like aluminum to MAO in a patient that is already compromised, and let's say it's a male patient that's compromised with MAO, you really have a tough time breaking down serotonin. And serotonin, just briefly want to mention, serotonin is a neurotransmitter that activates brain networks rather than individual neurons like dopamine, for example. Dopamine fires up your neurons, mostly in your frontal lobes, to fire up, and dopamine, for example, is very important in critical thinking, in, being creative, to do math, to have a broad mind, to be very flexible. And serotonin is different because it rather activates brain regions. And that will come in very important when we talk about high-functioning autism versus low-functioning autism. On this side, you see the most critical gene that I mentioned, MTR, is also affected by heavy metals and toxins, such as aluminum, acetaldehyde, which is very important because Aspergillus mold, yeast, produces acetaldehyde. It's a byproduct. Mercury, lead, nitrous oxide, that becomes critical when we talk about sending our autistic children to the dentist. I've written many letters to dentists and children that require surgery to write letters to these anesthesiologists that please do not use nitrous oxide on my child, because that can very powerfully paralyze this gene for several months, up to several months, and has been described to even cause death in certain cases. Hydrogen peroxide, so inflammation, is inhibiting this enzyme, and also high levels of SAMe. And that's why we have to be very careful in providing SAMe or high doses of methylated supplements to these patients. In fact, I rarely to never provide methyl B12, methyl B9 to any of my patients because it usually backfires, because it actually also stimulates the production of adrenaline. It also helps, of course, with the breakdown, but if you have a net effect of this gene being affected, then the net effect is accumulation of adrenaline. So methylated products, I'd be very careful about. But you see now that the ultimate problem is that these genes are paralyzed and these neurotransmitters cannot be broken down any further. Furthermore, if you have MAO, a problem with it, and for example, an exposure to aluminum, then the serotonin cannot be broken down very well. And serotonin is a very potent inhibitor of COMT. So it adds fuel to the fire, basically, because we already have that compromised because of no SAMe. And the consequence of that would be very, very high levels of adrenaline. And again, we can plug that into what we've discussed previously, creating high levels of cortisol, high levels of immunosuppression, and further mold growth. Now, this is where it gets really interesting. And this is, in my opinion, really getting down to the core reason of what differentiates a person with just gut inflammation and mold to a person that's actually autistic. And so let's assume we have a patient that had exposure to aluminum and had these genetic predispositions to get to the point of having high adrenaline. So what then happens is that adrenaline is breaking down in a different way. If we cannot do it enzymatically or genetically, adrenaline needs to get rid, the body needs to rid the adrenaline in a different way. And in the body, it gets oxidized. And it gets oxidized with these compounds here, such as hydrogen peroxide. Aluminum is also driving this reaction, as well as superoxide. So those are all compounds, free radicals, that form mostly in the liver. Why in the liver? Because in the liver, we have a lot of chemicals that need to be oxidized because there was no glutathione. And so basically, free radicals in our body are there to blow things up, to make them smaller, to break them into pieces so the body gets rid of them. And the same with adrenaline. And so the oxidized adrenaline is called adrenochrome. And adrenochrome is very interesting because what adrenochrome does, according to my research, and I can provide references to any of your listeners. I didn't put them on the slides, it would have been too much. But all of this is verifiable with research papers. So what happens now? Serotonin, how is that getting broken down? If you don't have that gene, you have the MAO problem, you have the aluminum. Well, what happens then is that there's a specific gene that can break down serotonin, and that's called INMT. And that is mostly present in the lungs, but also in the gastrointestinal system, interestingly. And so what happens now is that adrenochrome starts to stimulate that gene. And that starts to create a new substance called Bufotenin. And Bufotenin is a very, very interesting chemical. In fact, I think it is the core chemical that can explain low functioning autism. Why? Because Bufotenin is chemically, it's 5-HO-DMT. And if any of your listeners have heard about DMT, DMT is one of the most powerful hallucinogen known to man. It's used in shaman brews in the South American rainforest, for example, in tincture called ayahuasca, where they mix different plants, they drink the ayahuasca, and they have very profound psychedelic experiences. But Bufotenin still is a derivative of serotonin, and serotonin comes from tryptophan. And tryptophan is really the core of all of it. Tryptophan is the core of serotonin, and tryptophan is the core of Bufotenin. But it's also the core ingredient of psilocybin, which are also known as magic mushrooms, or NMDA, or mescaline. So all of these compounds, they are tryptophan derivatives, and serotonin, when you basically break that down to Bufotenin, these chemicals act on the 5-HT2A serotonin receptor system in the brain, which is known to create psychedelic experiences, and also involved in conditions like schizophrenia, for example, where individuals have hallucinations and are having bizarre ideations. But as I see here in the sequence, you can see, again, it's the serotonin receptor system. So Bufotenin still acts on these. If you look at one of the approved autism pharmaceuticals on the market, risperidol is an antipsychotic, and it's approved for difficult behaviors in autism. Now, the medication risperidol acts on I believe something between 15 or 20 different receptor systems in the brain. And one of them is the 5-HT2A receptor that Bufotenin would dock onto to create these psychedelic different realities. However, it is obviously, in my opinion, not a good choice because it's not very selective in regards to only blocking that receptor. And it probably or surely serves its physiologic function. However, if you overstimulate it with Bufotenin, you have these different realities. And as you can see here, I drew out the chemical structure of these molecules. And it's a little bit silly of me to do this, but you know, I like to go really deep and integrate other theories, but this is just for fun, really. But if you look at these chemical structures, for example, the adrenochrome that we mentioned, kind of looks like a rabbit, right? I don't know if you see that or not. On this side, you can see that the Bufotenin kind of looks like a caterpillar, a sad little caterpillar. And I wasn't sure if I was going to put this in or not, but you see the caterpillar here that is smoking the hookah is sitting on a mushroom. And like I mentioned, the DMT is very structurally similar to the psilocybin, which is also a tryptamine derivative, causing visions, psychedelic visions, such as, you know, Alice had. On the other side, you know, the rabbit has its own function in this story, and is at least very interesting. I have a lot of more information about that, but I spare you. So, for example, in the literature, we can see that Bufotenin is identified in patients affected with autism in multiple papers, specifically also in the gastrointestinal system and in the urine. But as early as 1973, we can appreciate that this has been at least discussed to be present in autism. And most recently, from Italy, in 2010, they measured the urinary concentrations of Bufotenin in autism and schizophrenic patients, and it was striking how significant it was that they were affected. I think, as far as I know, there were 19 out of 19 patients affected with autism had elevations of Bufotenin, and then they had about 200 controls, and only 2 out of the 200 neurotypical controls had elevations in Bufotenin. They also measured this in intellectual disabilities, formerly known as mental retardation, and all of these patients also had elevations of Bufotenin. So the reason I'm mentioning this is because I truly do not believe that autism is any sort of brain damage or structural damage or, you know, some gene that we haven't discovered yet. I believe these children simply live in or experience reality much different than us. If you know somebody or have ever experimented with psychedelic substances such as psilocybin, LSD, all of these being structurally similar, you hear from these individuals that have consumed these substances that there's a loss of time and space. The colors are more vibrant. They have out-of-body experiences, and all sorts of visions that they have, hallucinations, auditory, visual, geometric shapes. I mean, I have talked to many autistic patients in my office, and those that actually can verbalize how they feel. And when you ask them, do you ever see things that I cannot see? Do you see shapes, forms, colors? And oftentimes you hear that they can see people, they can see geometric shapes, they can see colors, they see things that we cannot. With Adrenochrome, we have lots and lots of research. I didn't want to bring up any particular papers here, but we know more about Adrenochrome in regards to research, in regards to the effects that it has, especially in the worlds of schizophrenia. But we have visual spatial distortions reported, time-space distortions, inappropriate laughter, anxieties, bizarre ideations, paranoias, and hallucinations. Most of hallucinations are auditory, about 80%, but we also have visual hallucinations as well as taste and smell, which would explain a lot of these selective food choices that these children have. So let's talk about these patients, patient A and patient B. Some testing was done with these patients, and these are, let's call them imaginary patients at this point. One of the patients is 9 years old, has moderate autism. Some of the symptoms include hand flapping, minimal words, toe walking, stimming. It's a very active child. Inappropriate laughter was reported. At times looking at his hands strangely as if he was hallucinating. The child has sleep problems, attention problems, and however, despite all that, has an outstanding ability to draw and play the piano. On the other side, we have his brother, who's 11, and has more the Asperger spectrum of the autism side. And with him, he's more on the high-functioning side. He's outspoken, and he's very intelligent. He could tell you what day Christmas was in 2002 with the snip of a finger. He has a musical memory. He has a precise geolocational memory. However, he also has attention problems, and at times he's impulsive with a little bit of self-injurious behaviors. So what was done is these tests. So we have a genetic test. In my practice, we use MaxGen. There are others, maybe even better tests. However, I really like this one because it's visually very appealing to the patient. It's explained very well, discusses a lot of things that we're not discussing today. However, I've pointed out some very important genes that were abnormal in this case. Abnormal, rather not abnormal, none of them are really abnormal. They're really just abnormal if you have the right mixture of epigenetics, the environment mixing with these genes. And that's why these are rather genetic susceptibilities and not necessarily pointing to any specific disease. And these patients also have done mycotoxin testing, as we all know. Great Plains Laboratory offers this test. There are other companies that do, but this one is great. Correct me if I'm wrong, but I think it's checking 14 mycotoxins, which comprises 45 species of mold. Remember, there are over 200 species that we know of mold. There are mold species in the world that we most likely have not discovered yet in some remote areas of the world. in this case, we check about 45 of the most common species of mold, which all can be comprised in 14 different toxins. And so in this case, this patient had 4 elevations of mycotoxins. These are toxins that the mold actually releases into the liver by itself on a day-to-day basis. And this patient has also completed a neurotransmitter profile, which is a urine test that can be done, which has been shown to be reflective of the neurotransmitter levels in the brain. There are 18 markers that are measured, but the most important ones are listed here. The same with patient B, the most important genes mentioned here. And as you can see here, a little bit of a difference in these both patients, if you just glance at it, is that patient B has less problems with these specific genes and much less in regards to the mycotoxins. So at this point, I need to probably put it back to back. Or side by side, rather. So now, not to kill you all with death by PowerPoint, but let's go through the most important slides again. So let's look at the different systems where we can plug in these genes. So for example, we have the gut. What genes, specifically in the MaxGen test, can we apply to the gut function? Well, the first ones, as we can see here on the right, are the CCR3, HLA, the IL-21, and MYO9B. All of these genes collectively describe your sensitivity to gluten. So in this case, patient A was positive for gluten sensitivity. So with that being said, anytime you have a gluten exposure here, gluten entering the system is not being processed very well genetically and gives you higher exposure in the peripheral blood, which then creates higher chances of autoimmunity as well as histamine release. Intergenic is a gene that is responsible to activate vitamin E. Remember, vitamins in general, when we consume them, they need to be activated. Just like we discussed earlier, the dietary folate from green leafy vegetables, for example, needs to be activated by MTHFR, among other genes, but MTHFR is the most common one that we know about. So the same happens with other vitamins. B12 was MTRR, there's B6, there's vitamin E, even vitamin C needs to be activated. And so intergenic is vitamin E. And the reason I brought it in here is because vitamin E is a very powerful antioxidant. And if we have inflammation here in the gut, a lack of vitamin E would basically mean you have more inflammation. MAO is important in the gut because serotonin is being produced in the gut and would be one of the explanations why Bufotenin tends to occur in the feces when it was measured in patients with autism. And of course, with the subsequent formation of the Bufotenin, the peripheral entry of that would ultimately go into the brain because Bufotenin, as I have not mentioned earlier, does cross the blood-brain barrier. That's why tinctures like ayahuasca that you, for example, drink have the same effect. After a couple hours, you can appreciate the effects. PEMT is a gene that's very important in the gut. PEMT is responsible to, once properly activated by methylation, the gene spits out phosphatidylcholine. And phosphatidylcholine is very important in new cell division. For example, the gut has billions and billions of cells, and they constantly regenerate. And that requires a lot of new cells. And phosphatidylcholine builds the membrane of a cell. It's a phospholipid bilayer. And, that's why the gut is a high turnover system cellularly. For example, if you are a patient with cancer and you undergo chemotherapy, the first organ that suffers is the gastrointestinal system. You start to vomit, you start to have diarrhea, you start to have malabsorption, you lose weight, you become cachectic, is because of the destruction of the gut. And in this case, with autism, PEMT, if you have problems with that, definitely would not help because you would have less ability to regenerate. SOD2 is a very important gene because SOD2 reduces free radicals very powerfully. And it's interesting because we have SOD1, 2, and 3, and SOD2, particularly in both boys here, you can see they're both homozygous. They're both affected with that. SOD2 is simply the number 1, 2, 3 is relating to the location in the cell. SOD1 is within the cell cytosol, protecting the cell from free radicals in the cytosol. SOD2 is the enzyme present in mitochondria. So SOD3 is on the outside membrane of a cell, protecting the cell from outside free radicals. But SOD2 lack, when you have inflammation, destroys the mitochondria in the cells. And if you have poor PEMT cellular repair, and you can see here in patient A, he has a homozygous and a heterozygous version of PEMT affected. And in this case, with patient B, for example, we have 2 homozygous genes affected, 1 heterozygous. So that's pretty significant because now not only do we have a less ability to regenerate cells within the gastrointestinal system, mucosal cells, but when they are inflamed, the inflammation will rage. We have little ability to reduce the inflammation, the free radicals that get generated because of our lack of SOD2. And so that will really continue to fuel the leaky gut, the inflammation in the gut, and of course, attract mold in these areas. Now, next slide, I'm sorry. When we get to the part of the liver, a lot of genes are involved here. So, for example, as we discussed earlier, the very critical point to realize here is that the liver produces most of the glutathione. And which genes are responsible in the production of glutathione and in the function of glutathione? One of them is the NBPF3 gene, because what that gene does, it provides a very important building block for glutathione. As we mentioned earlier, glutathione is built from 3 molecules: glutamate, cysteine, and glycine. Now, glycine and glutamate, we don't need those amino acids in our diet at all. Our body can provide that by changing other amino acids around. But the third ingredient to build glutathione is cysteine. And cysteine needs to be in our diet. It's an essential amino acid. And cysteine is present in cruciferous vegetables, for example, in broccoli, in cauliflower, in fermented foods, in eggs. And these foods have a lot of cysteine. Now, because we don't eat these types of foods every day, what our body does, because it's such an important amino acid for the production of glutathione, is that our body stores cysteine in the form of homocysteine. And homocysteine is really our reservoir. So if we don't eat any of those foods, we can just simply tap into the homocysteine to release the cysteine so we can then build glutathione. However, in order to tap back into our homocysteine, there's a gene that's involved called CBS. And CBS is the gene that taps into it that is stimulated by vitamin B6. However, it needs to be the active form of B6. And the active form of B6 is called P5P. When we eat foods rich in B6, such as legumes or fish or eggs, these foods provide the B6. However, this gene called NBPF3 activates the B6. And if you have a problem with that, well, then you don't have the B6 to tap back into your homocysteine, which then ultimately leads to low cysteine levels and low glutathione. So that is one of the reasons why we need P5P, the active form of B6 in these individuals. And in this case, both of them are affected with this and leads to B6 deficiencies. Now, anybody could say, well, that's not true because I checked their B6 level last week. Well, if you do a conventional blood test for vitamin B6, it doesn't differentiate between the activated form and the non-activated form. So despite your B6 level being very high, does not mean that you have the ability to activate it. So it wouldn't be really doing anything. Now, GPX is very important because GPX is a gene that reduces hydrogen peroxide. And as we saw earlier, hydrogen peroxide is a potent inhibitor of MTR, which inhibits methylation. And hydrogen peroxide also very powerfully converts the adrenaline into the adrenochrome. So we don't want these free radicals around. And that's why GPX is very important, because GPX reduces hydrogen peroxide. And this gene is stimulated by selenium. So a trace mineral, selenium, is required for that gene to pump up. Now, again, these genes are only affected, GPX, in patient A, for example, and not in patient B. So patient B has a better ability to deal with free radicals than, or at least with hydrogen peroxide, than patient A. And in order for GPX to function and reduce hydrogen peroxide, we also need glutathione. So if that's low and you have GPX affected, you can appreciate how much of the hydrogen peroxide will really be around to cause these inhibitions and inflammation. VDR, these VDR genes are vitamin D receptor genes. So these are genes that actually produce the receptor on the nucleus of the cell. So these are receptors right on the DNA. And if you activate them, they have different functions. Vitamin D, first in the periphery, needs to be activated by the kidneys, by the liver, by the skin, by sunlight, and all that. However, if you don't have the receptors for vitamin D, you literally need higher levels of peripheral vitamin D. Vitamin D is important because vitamin D is actually a very powerful activator of GC-MAF. And many of you have heard of GC-MAF, but GC-MAF is a substance that our body produces. GC-MAF is G protein macrophage activating factor. So vitamin D helps ultimately with activating macrophages. Remember, macrophages are our little Pac-Mans that start to eat up protein. And we don't want the protein to enter the peripheral circulation. That's why vitamin D is so important to, at least, if we cannot bind it to glutathione, give our macrophages a chance to chew them up before they enter our blood. And so in this case, vitamin D was affected in patient A on 3 of the vitamin D receptor genes, but only heterozygous. So it's not the worst. But as you can see here, patient B only had 2 affected. Sometimes we see patients that have none of them affected. Sometimes we see patients that have all 3 homozygously affected. And so we need to definitely pay attention to that, to look at it from all sides. So this is the way then to strengthen the liver. I often provide glutathione to my patients that are affected severely with the liver as kind of a head start while we unlock and drain the homocysteine. Oftentimes we measure the homocysteine as well, and provide the activated form of B6 to do that. N-acetylcysteine, which is NAC, it would provide the cysteine. I take it myself every day. It's a great nutrient to have because it provides, again, the third essential nutrient for the production of glutathione. And it has been shown in many studies that supplementation of NAC does increase your production of glutathione. So how I would approach this then is is to provide glutathione or suggest it to one of these, or both of these patients, at least for a while, until they start to tap into their own resources and produce their own glutathione. Then you can discontinue the glutathione. I don't think they need to be on it forever. It's usually a fairly expensive supplement. Now further, this is very critical because once we again talk about the histamine being released, obviously there are genes that break down histamine, and many of you know this. For example, DAO stands for diamine oxidase. It's a very powerful extracellular enzyme that would tackle all of this histamine to prevent that this would stimulate, the adrenaline release. This is part of the reason why, for example, gluten, by the way, causes, in my opinion, eczema, or it causes these kids to sneeze or, have rashes all over, is because of the histamine. But DAO, let's look at that. What are these patients' abilities to break down the DAO? In patient A, we have both of them. The HNMT is an intracellular enzyme that breaks down histamine. And we can see here that all of the genes checked, the patient really has all of them affected. 2 of the DAO genes and 1 of the HNMT genes. So patient A has significant problems with histamine. And as we can see here, this patient has significant sleep problems. And that is partly due to the histamine, which stimulates the adrenaline, which then stimulates cortisol. And as we said, cortisol suppresses melatonin production. In patient B, we have 2 of the DAO genes affected. However, patient B does not have significant problems with sleep. And of course, we cannot explain every symptom with just looking at a couple of genes. However, in this case, is working pretty well. Now, where are we? So let's talk about the histamine with the adrenaline production in regards to the genes. Yes. So if we go to this slide, we can appreciate that patient A and patient B are affected with slow versions of MAO. And it's slow because, sometimes, not to make anything more complicated, but sometimes when we have genes that have a variation in them, sometimes they can also work faster. And most of the time they work slower. However, there are certain genes like COMT and MAO, and in fact also MTRR, that can make these genes actually work faster. And in this case, however, both of patient A and patient B have slower versions of MAO. And like we said, they only unfortunately have 1 copy of that, so they have slower versions. And these patients have significant exposure to aluminum, potentially also acetaldehyde, because we know that they have mold overgrowth. But that would mean in these patients that serotonin should be higher. And when we look at the neurotransmitter test, for example, on patient A, we can see that the serotonin level is very high. And the tryptamine level was high as well. Again, tryptamine is the immediate building block for serotonin. And it's not the immediate building block, which is actually 5-HTP is the immediate precursor to serotonin, but tryptamine is the core. And you can see everything is kind of backed up in this patient. Not only is MAO paralyzed, but possibly also aluminum. And I'm not sure if this patient had a hair analysis done, to see if aluminum levels were high, but I certainly have seen my share of high aluminum levels in the hair heavy metal analysis from Great Plains. So in this case, high serotonin, low epinephrine. So we said earlier, well, don't these kids have high adrenaline? Well, they do. However, when we cannot break down adrenaline, again, the problem is that the adrenaline starts to oxidize very quickly into the adrenochrome. And we know that because serotonin inhibits the COMT. In this case, the patient has a slower version of COMT, which means high levels of adrenaline. And the adrenaline then, again, oxidizes into the adrenochrome. And the adrenochrome stimulates the serotonin to produce the Bufotenin. In this case, with patient A, would explain more of the severe features of autism because he's detached from our reality. For example, looking at the hand strangely, stimming, whatever function that has when you're on that side, is it to ground yourself, to remind yourself that you're still there? The inappropriate laughter could be explained with that. It has been described by patients that have that were injected with adrenochrome that once you start to flap your hands, is that the hand motion remains static, and that you basically can see your hands in all planes that you have moved it in. Which, when you look at a child with autism, when they flap their hands and they would remain static, it's almost as if they're building a cocoon around them because of whatever they might be frightened of what they're seeing. That would be my explanation in that regard. But the Bufotenin that would most likely to be occurring in patient A would also create potential hallucinations, auditory, visual, and that's why oftentimes, even in my own son, I see they're holding their ears despite really no noise around them that could irritate them. Why is that? It's because potentially they're hearing voices. Unfortunately, they can't tell us oftentimes in severe autism, but that would be the explanation for that. Now, what is very critical here is what differentiates a low-functioning person from a high-functioning individual. For example, in patient A, we mentioned that most likely the Bufotenin production is very high, which would project him into these altered realities. However, in patient B, we don't really see that. He's outspoken. He's very sharp in regards to his memory, however, he has also attention problems, and he also has at times self-injurious behaviors. So what is the difference here? Well, the difference is that if you look at his genes, is that he has a fast version of COMT. And when you have a fast version of COMT, you actually break down the adrenaline correctly. Let me find the correct slide here. Here. You break down the adrenaline actually faster. And so that would mean that there is really not a lot of adrenochrome present. And when you don't have as much adrenochrome present, you don't have a lot of substrate to oxidize the serotonin. And that is very, very critical because serotonin by itself does not induce a state of hallucinations. It does not activate the 5-H2A receptor like, for example, Bufotenin or DMT or LSD or psilocybin, for example. These are much more powerful binders to this receptor inducing these states. Now, not in this case because he doesn't have the Bufotenin. However, it doesn't negate the fact that this patient still has very high serotonin levels. So as you can see here, serotonin and tryptamine are also very much elevated in this patient. And like we said earlier, serotonin in high levels does induce brain networks. And that would explain why some of the regions, it appears, in patient B seem very profoundly hyperactivated by these high levels of serotonin. and would explain his photographic memory, his precise geolocational memory, his ability to tune into music and learn how to play an instrument at the age of 11. I certainly could not do that. And so that would explain the difference. And so it's a very small difference, simply that one of the children, in my opinion, produces Bufotenin, the other one does not so much. And overall gives you the difference between low functioning, high functioning. Now, there are other things, very interestingly, in both children, if you look at their neurotransmitters, they were both normal. You would expect really that they would be, grossly elevated. It's not the case. And, we don't see that a lot, despite, the links to schizophrenia and so forth, where Western medicine believes it's simply due to high dopamine, which in my opinion is not correct. It's because of adrenochrome in schizophrenia, in adult schizophrenia. But the epinephrine was also low in patient B. And what's significant in both was that the GABA levels were very high. So GABA is an inhibitory neurotransmitter. A lot of people take GABA to fall asleep, to calm down, because it does regulate dopamine and glutamate and also serotonin. So GABA in high levels is inhibitory, meaning it slows down neuronal transmission. However, too much of it, of course, is not a good idea, because that can lead to mental fatigue, memory problems, and you just have brain fog. And so, interestingly, GABA is produced in the gut by bacteria, and I usually use GABA almost as a marker that you can tell that too many molecules of GABA are being produced in the gut, and that's mostly because of dysbiosis. And so we're not talking about only mold. Usually mold goes hand in hand with others like Clostridium and other bacteria that can cause inflammation and dysbiosis. And so high GABA levels are treated with theanine. Theanine is a supplement. It's a very nice supplement, but again, it would kind of inhibit to too high levels of the GABA, but it's not a core fix. It's like, I take a Motrin for my headache. That's great, but I want to know what caused the headache. So again, the solution would be, of course, to treat the gut with the dysbiosis. Patient B had high levels of histamine. You would actually expect it to be high as well in patient A, but again, not everything is explainable. But certainly he did have two DAO genes that compromised his histamine. I would think it depends also if, potentially did they have, specific different meals the days prior that are digested right at that moment when this was tested, when the histamine levels were up. So there are many factors involved with this, but histamine was high in this case. And then, how to address that again, I would address it with fixing the liver, fixing the gut. And, you can also have, the histamine block, for example, is a product from Seeking Health, which contains the DAO enzyme. I did not have much success with that with my patients. There are more natural remedies like Berber, for example, is a great one. There's a great product, Berber, forgot, Nutramedics, I think, makes it, and that acts pretty quickly. But also, for example, if you have problems with histamine stimulating adrenaline, there are supplements, and we talked about that a little bit before we started, Enrique, is hydroxyzine. Hydroxyzine blocks the effects of histamine, and that's oftentimes an ingredient present in antihistamines like Zyrtec, I think. So hydroxyzine is harmless, in my opinion. It's a prescription. However, talk to your physician about it. It really, if you have kids that have trouble sleeping, don't have much success with melatonin. Kids fall asleep and then they wake up again 2-3 hours later. Hydroxyzine, in my opinion, in these cases would be a better choice. Until, of course, you have better and less inflammation in the gut once you have that addressed. But if you want immediate relief, that would be a good option. Other than that, the glutamate levels in patient B were high. Usually, that would reflect, in my opinion, more brain inflammation in patient B. Usually, it's probably these hyperstimulated areas in these patients that produce some sort of hyperstimulation of certain neurons, and the neurons in response, once they're inflamed, release more glutamate. Now, in regards to the mycotoxins, a lot of success has been reported with the use of anti-mold, antifungal medications, such as Sporanox. The generic name is itraconazole. I'm not advocating that anybody take this, but of course, do your research, talk to your physician about this. I have treated patients with itraconazole very successfly. I have about 10 patient reports that just get back to me with patients telling me what a significant change that has made in their children's lives. If you want to research that yourself, there's some incredible resources at the, for example, Great Plains Laboratory website at greatplainslaboratory.com/articles. See all kinds of evidence of mycotoxins in neuropsychiatric disease, including autism, what kind of treatments are besides antifungal medications, and of course a very vast archive of mycotoxins mentioned in the literature that are peer-reviewed articles that you can click on. For example, here, this one, the role of mycotoxins in the pathobiology of autism. I think they also added that case of Dr. Baker that you have interviewed, in New Jersey, a holistic practitioner who had incredible success with treating a 4-year-old boy with severe autism with itraconazole. And once they have killed that mold, this child basically completely reversed and came back and lost the diagnosis of autism. So, and that case was published. And of course, there are more good references in regards to that. So with that being said, there are many more genes that I didn't mention, but I think that those were the most critical ones in regards to these patients. I think that kind of pointed out the core areas that I wanted to address. So if any questions, Enrique, or any of the audience members have questions, we can talk about it.
Lots of comments, Doctor. Lots of questions from myself and the audience. I think this has been tremendous. I really appreciate you taking the time to walk through all these material, and also to specifically address like each specific area with these tests. I think that really helps to have a better perspective, as opposed to being something that is just theory, to be able to link this with actual cases. So thank you for that. I certainly have several questions from everyone, but I think I would just like to step back a little bit and go through some of the things that you touched on, which I think were really, really important. So one of the things that you mentioned, was about the topic of leaky gut, right? And apparently this is a much bigger issue. I think that people appreciate, and also for all the reasons you mentioned, where the reason why everything starts there, and also the fact that, which I don't know, if, like, everyone appreciates how these different, things like gluten and casein and all these different things that are found in the gut. The gut reacts to these things as if they were infections. And when you have a lot of gluten, I mean, the gut gets inflamed, and you start like this inflammatory process, and gluten can stay in the gut for months and months and months, leaking things into the bloodstream, as you were mentioning. And also the same thing with casein and these other substances. So I guess one of the obvious questions is like, how can we address the leaky gut situation beyond just having like gluten free and casein free diets? I mean, what would be your recommendations on that?
Well, I like to make sure, first of all, of course, take a very detailed history of the child. Did the child have, for example, a lot of antibiotic exposure during pregnancy, after pregnancy? Was the child breastfed? Did the child have a lot of ear infections that were treated? What is the status of the microbiome? I don't like really at all. I used to test for these, stool tests, but remember, the gut is 20 feet long. The large intestine is just 1/4 of the length of the gastrointestinal system, and 90% of bacteria are reflected in the large intestine, where you take the stool probe from. But it doesn't really reflect the small intestine, where only 10% of our microbiome resides, and that's where most of the leaky gut occurs. And so that's why we have to do these different tests. And we check, for example, with the oat test, we check different toxins that these bacteria release. But how do we address it? Well, an oat test would be good to see the overall status. But I don't like to just throw probiotics at that. I like to know, why is this occurring? Is there a deeper reason, such as the case of immunosuppression? Let's have the immune system take care of it. It would be my approach. So how do we strengthen the immune system? Well, it's everything that we've discussed is to strengthen the liver. The liver is our immune system. It's where the biggest fights occur. And so to strengthen that with glutathione, with the production of it, with methylation, stimulating or looking at methylation problems, but then also to stimulate the gastrointestinal tract to function correctly. Oftentimes, like we said, because the inflammation and the inability to regenerate new cells, do we need to provide maybe some phosphatidylcholine? I like simple things like vitamin C, for example. Vitamin C is very toxic to a lot of these anaerobic bacteria, because anaerobic bacteria don't like electrons. And all vitamin C is a huge collection of electrons that are toxic to these bacteria. That's why when you take vitamin C, for example, in higher doses, you start to have loose stools. We call it, the bowel tolerance. It's because these toxic bacteria will start to come out. And it's not really diarrhea. Diarrhea usually has different reasons. It's osmotic regions or infectious reasons. But this is not a diarrhea that, when you take vitamin C, that you can become electrolyte depleted or of some sort. These are really toxic things coming out. And that's why after a while, if you take higher doses of vitamin C, you start to get rid of the loose stools. You have really nothing anymore. No more bloating, no more loose stools. But it's very, very important to supplement with vitamin C. And the reason is, if you look at your oat tests and you see that the vitamin C levels, should be between 10 and 200. If I usually have patients that have not been treated with vitamin C come in, their levels are literally zero, maybe 0 point something. But having no vitamin C in the peripheral blood is very bad. For one reason, vitamin C is required to break down dopamine to noradrenaline. High dopamine is ADHD. Low noradrenaline means they can't focus. And so just, those kind of things. Kill two birds with one stone. Keep the gut moving with vitamin C, clean out those toxic bacteria, and at the same time, reduce the ADHD and increase their attention. Nowadays, we circumvent that by simply giving Ritalin, which increases the noradrenaline and your concentration, but doesn't really address the dopamine. So we don't even know what Ritalin will do to any of these children in 20, 30 years. Could they have dopamine toxicities, Parkinson's, things like that? I don't know. But I'm not a big fan of those. So vitamin C is a big one. And then, of course, once you have addressed the mold at the same time, with, for example, if you go the route with the sporanox or itraconazole, and you really cleaned out the gut from this toxicity and the dysbiosis, that's when you can entertain things like prebiotics, for example. You can use probiotics. If I would do it only for a short time to colonize, but then the prebiotics to keep feeding them. And we use usually the, the inulin from the Jerusalem artichoke, I think, is a good choice. But that would be basically it, to restore the gut function very simply. I don't know.
I think one of the things that your presentation does, which I really liked, is that you're like looking at these these genes in connection to like mycotoxins or heavy metals, right? And it kind of brings into perspective the fact that you cannot look at these two things in isolation, right? Because you may ask yourself, whether or not your child has high aluminum, for example. Well, it really depends on your function of the gene, right? So if your gene is not working properly, maybe if you don't have a high read of aluminum, maybe just maybe normal, but it may be in the threshold of normalcy, that would still be an issue, right? So you kind of need to kind of look at these two things in perspective, and kind of analyzing these things in combination to understand what's going on. Is it not?
Yeah, absolutely. And that's why I'm usually not a big fan of chelation, because if you think about a child with high aluminum levels, why did Johnny have high aluminum levels and is autistic, but Paul on the other side got this same exposure to aluminum and he's not autistic? There's no chelation material that they've received. It's glutathione. Glutathione binds aluminum just like any other toxin. It's just that Johnny didn't have a lot of glutathione, and so that's why he has higher levels of aluminum. And so it doesn't make sense to me to throw in, and with all respect to those Andy Cutler followers and all of that, I mean, I've used chelation on certain patients as well, don't get me wrong, but it's not something I use routinely. I have kids with high lead levels, of course, it's actually indicated in high lead levels with children to chelate them. But I think glutathione does a great job with it as well. And, the problem is you start to chelate and you don't address what caused the high aluminum. If you have leaky gut, you have permanent aluminum absorption into your system. If you eat a pear, there's aluminum in the pear. Usually 99.9% of that aluminum runs right through you. The little that gets absorbed quickly gets excreted by the kidneys. But if you have leaky gut, much more will enter the liver. And you can start building your aluminum levels up with just eating regular foods. And that's why chelation, you have to look at the bigger picture. You can't just say, oh, take this pill every day and you'd be fine. Doesn't really make sense, because we do have to look at the side effects as well. It pulls out other minerals, and you kind of have to constantly take your kids, to get blood work done and all of that, and it's stressful. And so I don't know. It's in that regards, with the chelation, I'm not a big fan.
Yeah, I think another thing that your presentation does, it really highlights the underlying issues and how everything is kind of trickling down from these genetic susceptibilities that these children have. And I guess one thing that people are wondering is what causes these up or down regulating issues in the genes to begin with. I mean, could you shed some light on that?
Yeah, that has to do with the specific nucleotide substitution in these genes. For example, if there should be a T that makes the gene work normal, if there's a G, for example, it makes it faster, and the C makes it slower. And that's different to every gene. So that is based on research. That's why we don't have 20,000 genes to look at. We right now just look at very critical genes where we know that we have evidence-based research behind it. So, when we talk, for example, about COMT, one patient having a fast version, one having a slow version, that has to do with the specific substitutions in that specific gene. One makes it faster, one slower, and then we have a lot of research about it. For example, patient A having the slower version, they're in the research world considered worriers. So they worry more. Highly intelligent people usually, because it does usually create high levels of dopamine. So they're very intelligent people, but also more worried. It goes more into the schizophrenic realms. On the other side, patient B had a fast version of that. They are considered warriors, because they constantly crave adrenaline in a, let's say, neurotypical person now that doesn't have other critical SNPs involved and toxicities from the environment. But they're considered warriors because they like the adrenaline that drives them. And so those are the kind of individuals, specifically males, that have that effect that with the MAO would be, jumping out of airplanes, and they're thrill seekers, and rock climbing, whatever, roller coasters, anything that brings you adrenaline, they're craving this. And so that's what causes them to be faster and slower. It's just single substitutions that we inherited from our parents.
So how long, obviously it depends on the specific case and the severity of the case. But what would you say in terms of the length of the treatment? So obviously, everything you described is very complex, and it takes time for you to start kind of digging into each specific case, getting the history, getting the testing. What else? So I guess, if like in your experience, what would be a timeline if you could provide some sense for a treatment, right? So people can kind of see the effect of these different approaches that you're describing, depending on the situation. I mean, could you provide some sense so people do not expect like immediate results from one specific approach or another? What will be your opinion on like how quickly people can recover?
Well, I see patients that never had any testing done in their life, and they start from scratch, and they're not on any supplements. Then you have other patients come in that have every test under the moon, and they have been on every supplement under the moon, supplements that I've never even heard about, including herbs and all kinds of stuff. So the complexity is very, very broad. Not only looking from the genetic and biomedical aspect, but also the environmental influences. The parents, the complicity, are the parents, for example, are they living together or not? Because if one of the parents is not on board with it, well, if, one parent doesn't agree with the treatment and starts to feed sugar again on the weekends because he doesn't agree with it, there's so many factors that are involved with this. So we definitely have to take a very, very detailed history. And that's why when we sit down with my patients, really ask a lot of questions in that regards. What is the living conditions? And oftentimes it's very personal, but unfortunately that's what it takes. We need to dig in. We can't just say, oh, take this product or take this product. Does this work for autism? We need to learn about the environment that the child is exposed to, because the environment is really what influences these genes. And it's just as important as knowing that as these lab results. And so, I've done consults when I started with my child just like this, and paid money to doctors. And within 5 minutes, they started flashing their products. Oh, you need to this, and this. And like, you're not even listening to what I'm saying, about my child. And so I think every child with autism is different, just because of all of these influences from the outside. Do you live next to a golf course? Well, golf courses get sprayed with glyphosate. Glyphosate is very toxic to the gastrointestinal system. Maybe that needs to be checked. What does your child eat? What are the living conditions? How much stress is there? How many other siblings? Were there antibiotics used in pregnancy? Did you get vaccinated? Did mom get vaccinated in pregnancy? Is there mental disease in the family? Is there smoking in the house? There's just so much. Is there pet dander? Do you have pets? Do you have a histamine issue because of that? That is maybe unnoticed. And so it's an endless labyrinth And you will never get all the answers, but at least we can try with a very detailed intake that the patients can fill out before they meet. And then, of course, with a very focused discussion of the concerns, to just listen to the parent and see what the concerns are. What are your goals? What have you done in the past that has worked? Learn at the same time that you're discussing with the parent. Oh, okay, well, that's a no-go, because you tried methylated B9 already and the child did horrible. Those are very critical informations that you need to put in right at that moment to properly counsel patients of what the next steps are. But in regards to that, we had patients respond that you didn't expect that they could respond amazingly. I mean, there were patients that I couldn't stay in the room because they were so severely affected. We had to follow the parent around in the parking lot to get the questions in, because they had to look after their child during the consultation. And these children, I see now, for example, using this spell to communicate system, or literally spelling sentences. And so with at the same time, in my opinion, with the right biomedical approach, can work wonders. It's like a different human being. And that can be a great relief for the family. But in regards to response to improvement, it's variable. I have to be honest, there are children or families that have moved on because they didn't see results quick enough. And then, it's the expectations of the parent. But in general, and I voice and mirror the voice of Dr. Baker in that regards. If you see abnormalities, for example, like in patient A, where you have 4 different markers of very high levels of mycotoxins, I mean, that we cannot ignore that. That needs to be addressed one way or the other. The mold needs to be addressed either by strengthening the immune system or discussing if potentially treating these children with antifungal medication would be beneficial. But just like Dr. Baker said, usually you start to see some indicators that you're going in the right direction within the first 2 weeks. I usually, before this whole mold hype came out, and I love it because it's great, whatever works. But before that came out, I usually mentioned to the patients with the neurotransmitters and genetics and the other testing that we did is give it at least 8 weeks, to really start to implement some changes, because it takes some time until the body adapts to really switch some enzymatic systems up, to boot up some of these systems to really work, to bring up your stores. You have malabsorption problems, so you have to overcome those to bring up your levels. And for example, with the vitamin C, before you get the vitamin C to your brain, you need to break basically the GI tract. You need to break through that because it's an electron donor, and it's gonna go to whatever system attracts and requires those electrons first, and it's first come, first serve. We can't inject vitamin C into the brain, but it takes some time sometimes to have an effect. And so, for example, with niacin, if you look at niacin historically, which has been used successfully with Dr. Hoffer in Canada, he ran the largest psychiatric facility in the world in the 50s, 60s, and 70s. And he had about 5,000 patients affected with schizophrenia. And, all he did was vitamin C, glutathione, and niacin was this big thing. And, niacin is vitamin B3. It's a methyl acceptor. That's why niacin worked so well and still works so well, in my opinion, in patients affected with schizophrenia. I've had patients with that where we suggested niacin in high doses as the methyl acceptor. In my opinion, was absolutely incredible. But it takes some time. Niacin, for example, has a lot of side effects. You flush, you turn red, you get itchy. And so it's not for everyone, but you see the effects really start kicking in after 4 weeks, at least from my clinical experience. And so you have to tell the patients, what they're up against. They have a lot of itching, a lot of redness, and you need to take that 3 times a day. But in my clinical experience, it works amazing. So you have to set the right expectations to every patient. With autism, like I said, you'd be surprised how well some of these children respond, and then you'd be surprised on the other side as well, that you think you have it all figured out, and whatever you throw at them doesn't work.
I would just like to kind of voice over this comment, because I think it is reflective of my personal opinion about you, Dr. Bogner. It says, if only more pediatricians were like this doctor, instead of giving you the phone number of early intervention when your kid is 18 months, then it's off to the ABA issue, right? So I think that you have, this is a topic that you have personally actually addressed in another live session that we had, which is that, ABA, is great, but it's not really, shouldn't really be the first line treatment, as it has been suggested, or as it is suggested usually by physicians, and by having this approach of, like, forget for a moment about the autism label. Let's dig into what's really the underlying cause of this specific child situation. Let's position the child medically so that he is in a better position to learn. It's definitely a much more reasonable approach. So I'm just gonna I mentioned a few of the comments from people here. They're basically asking about, like, a specific test. If you could mention some specific tests. Do you have any preferences about tests, or do you think that it would really depend on the specific situation of the child regarding whether you would order a certain test or another?
Yeah, again, I never recommend any test to anybody unless we have taken a detailed history to see what the child needs, what the child has done, what the circumstances are. Often we also look at the resources of the families. Of course, we can't just say, oh yeah, buy $1,000 worth of testing. We have to prioritize sometimes, and so we work with families very, very closely to see really what is necessary, and educate parents about, what is this test going to tell us? Is it really necessary? Like, for example, with the genetics, I think without genetics, how can I make any recommendations if I don't know about genetics? To me, it's like Russian roulette. Oh, let's just see what works. It's absolutely, in my opinion, absolutely not the right approach, because for example, you have this problem with the vitamin B6. You can't activate it. Well, which form of vitamin B6 do you give? Do you give the pyridoxine hydrochloride, which is in most supplements, or do you go for the little bit more expensive version, the P5P, pyridoxine 5-phosphate, the activated version? Do you need riboflavin hydrochloride or riboflavin 5-phosphate? And so these are the little differences, that overall all start to come together. Because autism, in my opinion, is not going to be ever a one-pill solution. It's you have to throw many arrows at that beast of autism to have at least some improvement. And at least some improvement is really what I'm after, because some improvement, for example, less stimming or less tantrums or better sleep, just each one of those can change the whole family. The child sleeps better, I sleep better, I'm in a better mood, and maybe have more motivation to even dig deeper then. So one thing leads to the next, and genetics is really, in my opinion, not something that we can guess about. So the genetic test would be the most important, in my opinion. The neurotransmitter test, in my opinion, would be the second, because I don't know, if a child, for example, has high levels of glycine. High levels of glycine can cause cognitive processing problems, and the treatment for that is ALA. How in the world would I know that a child needs ALA? Because on the other side, the child could have low glycine, which causes a whole area of different symptoms, including schizophrenic symptoms. And so then glycine wouldn't be a good choice for that kid. And so the neurotransmitter, I think, are important to at least get a glance of what are your tendencies. Do you have super high dopamine or very low dopamine? If you have very low dopamine, you have addictive tendencies, and you have brain fog, and then the neurotransmitter test would tell us, well, do you have low dopamine because the building block of dopamine is low, which is tyrosine? because that is measured in the neurotransmitter test as well? Or is it something in between that doesn't work? Because you can have low dopamine and very high tyrosine. So for that low dopamine, you don't want to give tyrosine. You want to give what activates the gene that utilizes the tyrosine, which in this case it would be vitamin B6, the activated form. And then you look at the gene test again to see, well, does the child have the problem with the gene activation of B6? Which version of B6 do I give? So these tests are very critical, I think, the neurotransmitter test and the genetic test. It's a luxury to have the mycotox test, of course, to show evidence to the parent, that, hey, look, gliotoxin is high, It's a toxin that inflames microglial cells. It can explain a lot. It suppresses the immune system. And bring it to your pediatrician, see what they say. And you have a lot more leverage in that regards. You can have these medications covered by the insurance companies. And when you have evidence of, mold. And so these would be the tests. Of course, an OAT test is great to give you an overview. I don't really do much beyond that. Stool testing, I don't really do. I don't, the FRAT testing, the FRAT testing, I don't know if it's necessary. You just treat with folinic acid. I think that would be the way to go, but why spend the money for that test? And I have no financial relationship with anything, with any, I'm self-employed. I don't have any relationships with any of these companies. So I'm choosing them because of years of using other tests. I used to check for glyphosate, GI map, Nutraval. They didn't really help me, especially these stool tests. I think they're all really, I see high levels of staphylococcus, on the GI map, or high levels of some other bacteria that you've never heard about. And so what are you going to do about it then? Is there a specific protocol that you need to follow if you have one of those very much elevated Klebsiella? What are you going to do about it? Do you give an antibiotic? No, that's a bad choice. The question is, why do you have dysbiosis? I don't know. These are expensive tests, and we have to be careful what we're asking for, because then you get abnormal results. The patient is excited. Oh my God, the GI map showed 6 things in red that are elevated. And then you sit here on the other side and you're like, okay, I really don't know what to do. I can't tell you anything more than I knew before, because, and again, these tests, we have 1,200 different species of bacteria that live in us, families of bacteria, and each one has often hundreds of different subtypes. And so these tests are just a sandcorn on a big beach, that it's, I think we're still need to do a lot more research in that regards, how we can utilize these tests more specifically. But, I would rather skip those tests and spend money on, when the time is right, on the right prebiotics and probiotics. But even with that, I don't have revolutionary results, with all the respect to all of those that did. But think about it, probiotics, it's 2 species of bacteria, really 3, but that are legally allowed to be put in a supplement. It's lactobacillus and bifidobacterium, and then there's strep. Streptococcus thermophilus, I think. And then you have all these different bifidobacteriums and all of the different lactobacillus species. But those are only 2 out of 1,200, really. So that's why I think, Dr. Adams and researchers like this are very valuable to see. Maybe it's more valuable to look into that and to, could a stool transplant, for example, be beneficial? Again, I don't have a lot of experience with that. I have patients in my had patients in my practice that had multiple stool transplant that still come to see me and seek help, which is unfortunate. They spend lots of money. It's oftentimes requires strenuous travel and swallowing these pills and doing these enemas and but God bless the people where it helped, and these researchers that research this, but I'm not really a fan of that because, again, what cost the microbiome to be imbalanced in the first place. And if you don't correctly imbalance the immune system, you're going to get it right back after a while. Just like you treat somebody with autism with vancomycin, big gun antibiotic, wipe out all the bacteria, they do much better. The moment you discontinue it, it comes back with a vengeance. And so looking at it rather from more angles, and I think those tests give you a good viewpoint on those issues.
Dr. Bogner, we're actually closing. We're close to 2 hours with you, and it's just been a blast. You actually made us realize. I mean, we have this rule that we don't want to go over an hour with doctors because we believe that people are not going to watch it. You actually changed that perspective we had last time, because you went like for 90 minutes, and it's been one of the most watched live chats that we have had here at the Autism Restoration. So I mean, thank you so much for your generosity and spending so much time with us, and also preparing this presentation for us. I mean, that has been fantastic. I just wanna mention something that you mentioned, like super quickly. You said whatever works, right? And I wish people or more physicians would have this attitude, right, of looking for every possible option, not leaving any stone unturned. And there are actually patients here that I'm just going to read some of these comments. Dr. Barnes said to me, "We will not give up trying to heal your boy." Not many doctors ever say that. Seriously, this is gold. And I completely agree with that. We have also this other comment. He told us the goal is the 100% and no more need to see you or get any treatment. That is medicine. And I definitely agree with that. I mean, I've known you for a little bit now, and I can totally relate to this. I mean, you have said similar things to me, and we know your passion. We know how much you care. I wouldn't want to mention like everything you have needed to go through, but I'm certainly looking forward to see you shine in your new practice, Dr. Bogner. So this has been really phenomenal, and we really appreciate your time. And any final remarks from your end?
Well, God bless you, Enrique, for doing all this. You working so hard to bring all of these people together. It's like a continuous Autism One that you have on your forum. It's incredible. These people, I learn every day. I don't want any of my theories to be right, or I don't want to be recognized for that. I have only one goal in mind, and that's, to help each individual, just like I want to help my child, because I'm affected. I know how hard it is if you have your child not able to communicate and, oftentimes be miserable, self-injurious. I mean, who wants to see their child bang their head against the wall or smear poop on the wall? I have lived all of this, and I don't want autism. There are people that say you need to accept it. It's God's blessing, don't do anything. I don't accept that, because I have seen what it can do if you intervene. It doesn't work for everyone. But if you have a motivated parent that says, all right, this didn't work, they don't get upset and go to the next doctor. They continue to work. They go, and turn the next stone with you. Let's keep trying, And I had patients like this. We tried everything. And then we kept trying. And then we kept trying a little more. And then finally, they found what they were looking for. And they have never contacted me really since in my office. They told me, hey, we continue to do great. It's amazing. Thank you so much. But they don't need to see me anymore. And that's when really you can say, all right, this really worked out great. And that's the biggest satisfaction that I'm seeking. I'm very dissatisfied if I have patients that do not have improvement. I don't want to sell any products or tests or anything like that. I want to help you just as much as I would help my child. And my goal is to see you as little as possible so we can help somebody else. I mean, we have 88,000 new cases of autism. That's a football stadium of new cases of autism every year in this country. And we need more doctors that speak up and learn about these biomedical approaches, because they work. In the majority, they start working. I started with this. I didn't have much success, but you just learn from the parents what they have tried. It's so complex. And over the years, I think we finally, I've gotten to a point where we help more children than not. And once you get to that point, it's really, it's not about fame or making a profit. It's about helping more and more children. And I would love to continue to come and work with you, Enrique. I've learned so much from you, trust me. Probably I've learned more from you than you've learned from me. And that's what it's all about. It's a collective consciousness that we all have to target. You know, it's not only doctors, it's not only researchers in the big universities, it's the parents I learn from the most. I want to see more patients to learn from them and see what works so we can help others more effectively. And that's why I think we need to continue on this journey, and next year we probably be much smarter than we are this year, and eventually we get to the point where we really have this nailed down and we can be more specific in what we recommend and how we treat. And I think we're much further along than we were 10 years ago, for example. And so yeah, that, you know, we could speak all night, I guess, but
yeah, we could definitely would. And I just want to say, I mean, you know, it really takes a humble, passionate guy like yourself. I mean, you know this, doctor. We love you. We are very, very appreciative.
And I love all of you. I really do.
Of everything you do. And we feel your passion. We you know, my heart breaks for your son and for, you know, the you know, the sons of all the people that are watching, that are desperate for answers, and you're really a shining light in this very dark world, and we're very, very grateful to have you, you know, fighting for our families, and we'll do everything in our power to continue to you know, help your practice in any way we can. I mean, this is definitely super important. You know, I would like just to kind of encourage you to watch, to look at all the love and all the support in the comments, because it's just overwhelming. I mean, I could go like all night just showing the comments of appreciation and love for you. But yeah, I'm really very, very grateful, and as we all are.
Thank you,
for
Rick.
everything you do. So
I did promise a shout out to all the people in California that are struggling with the fire right now. We're praying for you, praying for all of the people in Afghanistan, Americans and Afghani people, and my friend Dwight, who helped me so much, my wife, and of course my brothers in Germany, and all of the warrior moms that are so close to me. We will do it. We will continue to fight. And I love all of you. Thank you very much.
Yeah, I'm just going to put here your information. People have been asking, you know, where is this going to be located? All our videos remain live on the Facebook page of the Autism Risk Coalition, and also on the Autism Risk Coalition channel on YouTube. And also we have an account on Twitter, so you know, you can share, you can watch later on, and you can also see at the beginning of the presentation, Dr. Bogner showed this information with his new contact information, so you can see, you know, the contact info of his new practice. Dr. Bogner, this has been amazing. Thank you so much for your time, and we look forward to having you back.
Thank you so much. And you can always visit my Facebook or email me or come to my website and schedule an appointment. Thank you very much.
Thank you.